Right, so today we're going to do the last section of stoichiometry, and this is volume relationships in gaseous reactions on page 198 of your textbook. Now, this section is very simple, and it's basically just working out the amount of volume of product you get in a certain reaction. Now, when you're working out the number of products you get, or the volume of products you get in a certain reaction, the volume of the product that you're calculating only applies to products which are gases. So basically, if you do a certain chemical reaction and you get products which are gaseous in phase, and you know when something is a gas, you will see the small letter G. So only when you have products that are gases, then you will try to calculate the volume of those gases that you are going to produce in the reaction. And this section is just all on calculating the volume of products you are going to make only if it is in gases. So it only applies to gases. So if you see liquid, aqueous, or solids, you're going to ignore it. It's only specifically for gases. Now, this is the same as the normal stoichiometry, which we always do, where you calculate moles, and then you use the ratio, then you calculate moles again. It's basically the same thing over and over again. The only difference is that we're going to use this formula, which is the ideal gas formula we done before, which is PV is equals to nRT. So the only difference is we're going to incorporate this formula into our calculations. And remember, before we said that this formula has specific units, so you cannot just use any units in this formula. You need to use a specific type of unit for each thing, and then only this formula will work. Right, so if we look here, can you see PV is equals to nRT? P stands for pressure, and pressure in this formula is always calculated in pascals. So if you have kilopascals or atmosphere or any other unit, you need to convert it to pascals. Then volume in this formula is calculated using meter cubed, and normally we always use decimeter cubed for volume, but only in this formula the units for volume is meter cubed. So you're going to have to convert everything to meter cubed. And then it's equals to nRT. N is just moles, so that is normally how you're used to it. R is a constant, which is with the value of 8.31. And temperature is calculated in Kelvin. Remember Kelvin, we did it before. You just have to take the degrees Celsius, add 273, and that will give you temperature in Kelvin. Right, now we're going to use everything exactly like how we used to before with normal stoichiometry. Only at the end, when we are trying to work out the volume of the products that are all gases, then we're going to use this formula here, and the volume from this formula, this is the volume that we are going to be calculating. Right, so let us just do one example, which is on page 198 of your textbook, example 33. Now in this example, you have this reaction, which is 2 ammonium nitrate, which is a solid reactant, giving you 2N2 plus 4H2O plus O2. Now if you look here, this reactant is a solid, but all of the products in this formula is gases. Can you see? Nitrogen is a gas, water is a gas, oxygen is a gas. So every single 3 of these products here are all gases. So this question tells us to work out the volume of gases that we are producing in this reaction. And since they are all gases, we're going to work out the volume of all of these. Right, now they told us that we started off with 50 grams of ammonium nitrate, which is the reactant, and from there we need to now work out the volume of gases in the product. And they also told us that this reaction happens at a pressure of 101,300 pascals, and the temperature is 300 degrees Celsius. Now you guys can read the full question or the full example on page 198, but I'm just going to show you the main ideas of how to calculate this. Okay, right, now the first step is, before we can use this formula to work out volume, they gave us the mass of the reactant, and from the mass of the reactant we're going to use normal stoichiometry, where we work out the moles of the reactant, and from the moles we're going to use the ratios and work out the moles of each one of these products. And then once we have those moles, then we can use this formula, PV is equals to nRT. Now there's 2 ways of doing this calculation, but I'm going to show you the one which I think is the easiest, and you can decide whether you want to use this one or you want to use the other method, which is on page 199, and you can go through that one. But either way, it's both going to give you the same answer. Right, now the first step is always to calculate moles of the reactant, which in this case is ammonium nitrate. So this is just using normal stoichiometry, which we have always been using. So we're going to work out moles of the reactant, and they gave us mass here. So we're going to use the formula N is equals to small m over big M, and then the mass what they gave us is 50 grams, so there I put 50 divided by the molar mass, which of ammonium nitrate is 80 grams per mole, and that will give you 0.625 moles. Right, so now that we have the moles of the reactant, we need to get the moles of all of these products. And the next way, after you get moles, you always use the ratio to get the other moles. Right, so basically step 2 is calculate the moles of all the gaseous products, and we do this using the ratio. Now, when it comes to this part, you only need to work out the moles of gases. So since here we only have gases, we're going to work out the moles of all 3 of these products. But if you had a reaction where you didn't have gases, maybe you had gas and liquid and solid, you're only going to choose what is a gas. Right, so for this one, we're going to do all of them. So we're going to start first with nitrogen, and for this we're just going to use ratios. So you can see from the reaction you have 2 ammonium nitrate is to 2 nitrogen. So the ratio is 2 is to 2, which basically means the moles of ammonium nitrate is equal to the moles of nitrogen, which is also 0.625 moles, which we had before. Right, then we're going on to the moles of water, which is the next gaseous product. And here you can see the ratio is 2 ammonium nitrate to 4 hydrogen. So the ratio is 2 is to 4. So whatever ammonium nitrate is, water is double. So from 0.625 times 2, you'll get 1.25 moles of water. Then the last product is oxygen. And from here you can see the ratio is 2 ammonium nitrate is to 1 oxygen. So the ratio is 2 is to 1. So whatever ammonium nitrate is, oxygen will be half of that. So 0.625 divided by 2 will give you 0.3125 moles. Right, so that is step 2. You worked out the moles of each of the products that are gases and only gases. Then step 3, which is always almost the last step, is to add all of the moles that you have and then use the formula PV is equals to nRT to calculate the volume. Right, so first we have to add up all of these moles. So we're going to add the moles of nitrogen, of water, and of oxygen. So we're going to say 0.625 plus 1.25 plus 0.3125, and that will give you total moles of all the gaseous products to be 2.1875 moles in total. And this is only the moles of the gases. Just remember that we're not working with solids or aqueous or liquids. It's only for gases, and that's it. Right, so now once we have the total moles, we can now use this formula PV is equals to nRT, substitute all the information we have, and then calculate volume. Right, and the moles that we're going to use in this formula is the total moles which we have calculated just now. Right, so you can make volume the subject of the formula and you'll get nRT divided by pressure. And the moles is now the total moles, which is 2.1875. So remember, if you added it, you're going to put the total moles. Then R is a constant. It will always be a constant, so you don't need to calculate it. And the constant is 8.31. And then T is temperature. Now remember we said for when you use this formula in a unit, you need to have specific units. And for temperature, the unit is Kelvin. So in the beginning, they told us that the temperature is 300 degrees Celsius. So to convert it to Kelvin, you will say 300 plus 273, which will give you 573. Right, and then you're going to divide that by the pressure. And remember, we said pressure in this formula is in pascals. And since they gave us pascals in the beginning of the question, we can just substitute it as it is. So it's 101, 300, and there's it there. And then all you have to do is solve for V, and you'll get 0.10282 meter cubed. Now, normally, volume is always calculated in decimeter cubed, but for this formula, volume is in meter cubed. So the answer that you're getting here is in meter cubed, and then if you want to convert it to decimeter cubed afterwards, you can multiply it by 1000. But this step here for decimeter cubed is not necessary because volume is always in meter cube for this reaction, so you can just leave it as it is here. And this is basically it. So you're going to use normal stoichiometry for this section. The only difference is once you work out the moles of all your products, and only products that are gases, you're going to add them and use PV is equals to nRT to calculate the volume of all of those products. Right, and I also want you to read Chemistry of Airbags, which is on page 199 of your textbook. And this explains that airbags, you know how it works? It's basically a bag, and in that bag you have some chemicals, and when you have some kind of a collision or accident, it triggers off some kind of a reaction in that bag, and that reaction produces gases, and that gas is what inflates the bag, so it makes it big, so that you don't have to get hurt and hit your head on the dashboard or wherever, and you can hit it in the airbag, which is filled up with gases. And this only happens when the reaction happens. So just like how you have gases in normal products, the gas of the product in this reaction that happens in airbags also produces gaseous products, and that gas is what fills up the airbags.